So here is sample problem number 2 for law of sines and cosines. So again, this one, again, you will see I'll be giving you a triangle, and both law of sines and cosines will be applicable here. Again, you want to find all the three angles and all the sides of this given triangle. So here's the given triangle. So it's something like that, and I'll label this as, so this is B, this is A, and this is C. And we know that this is 20 degrees. And we know that this is 10, you could say millimeters. And then this is 15 millimeters. So we know these two side lengths, and we know that this is 20 degrees. And that's all we're given. We really want to find the length of this side, and we also want to know these two angles. So again, what will be our first step? Well, our first step would be to classify this type of triangle, and clearly by looking at this, we see that there's one angle that's located between two sides. Therefore, this classification is SAS. Right? This classification is SAS. Therefore, here we're looking at, we should be looking at the law of cosines, because again, we're dealing with more sides here. So we should try to find this side length over here, right? We know these two side lengths, we can find the side length here, because we know that this angle is obviously, it's facing, or it's opposing this side length here. So if we use the formula for the law of cosines, we should realize, we know that this side length is B, obviously, right? You can label that as B, because again, it's just opposing this angle denoted by the large, by the capital B, right? So this is the lowercase b, referring to this side length over here. So we know that it's B squared is equal to, you could say A squared plus C squared, right? A squared plus C squared minus 2AC cosine of B. So this is what we're looking at, right? So this is cosine of B. And really now we plug in the values, we see that we have B squared is equal to 100 plus 225, right? Again, 10 squared plus 15 squared minus 2 times 10 times 15, right? So minus 2 times 10, 2 times 10 times 15. And then we have cosine of, so we're looking at 20 degrees. So we have cosine of 20 degrees, right? So we have these values here, and now we just evaluate this, and you can plug this, basically this value here, and obviously that is equal to B squared. So you get something like B squared is equal to 43.09, and doing the square root, you see that B is equal to 6.56. So this is a value of B here. We know what B is now, right? It's 6.56. So that's just an approximation, and then we know that this is the value of B here. So it's the side that's opposite the 20 degree angle. So that's B. We know this is 50 and this is 10. So we know all first three sides, and obviously now we can apply the law of sines if we need to find the other the remaining two angles. But even before we do that, it's important for us to see if this triangle is a right-angled triangle, or if it's an acute triangle, or if it's an obtuse triangle. And again, the technique, as I said in the earlier or in the previous lesson, is to square the lengths of the two smaller sides of the triangle, and then compare it by squaring the length of the longest side of the triangle. So we know B is 6.56, right? And if we look at this, we know the smaller sides here are 6.56 and 10. So we're really doing 10 squared plus 6.5 squared. And we want to see what's the relationship between that and looking at 15 squared, right? So we see that 10 squared plus 6.56 squared, that gives us 143. And obviously 15 squared is 225. Clearly, this value over here is larger than the squares of the lengths of the two smaller sides of the triangle. Therefore, this classification must be that it is an obtuse triangle. So this is, we can say that this is an obtuse triangle because 225 is obviously larger than 143. Now we know this is an obtuse triangle, right? If this was an acute triangle, we use the law of sines then, and we find the angles, and whatever angle values we get, those are correct, because because all the values that we will be getting are going to be less than 90 degrees, right? Those are going to be acute angles that you get when you find the inverse using the sine function on your calculator, because all of those, all the values that your calculator gives you is less than 90 degrees when you're putting those trigonometric functions in. However, you need to understand that this is an obtuse triangle. Therefore, one angle here will be greater than 90 degrees and will therefore be the largest angle of the triangle. And clearly, we know that this is 10, this is 6.56, this is 15. Therefore, the largest angle is obviously going to be opposite to the longest side. Again, that's another rule that you should be aware of, that the smallest angle is opposite the smallest side, and obviously the largest angle is opposite the longest side. So that's the idea that you should know. So that obtuse triangle here, or not the obtuse triangle, the obtuse angle here within this triangle will be facing opposite this 15 milliliter side. So it will be this angle that we're looking at. So this angle will be greater than 90 degrees. Obviously, it's not drawn to scale, but you get the idea that this will be greater than 90 degrees. So now we are really gonna we're trying to find angle C, right? Angle C. And so to find angle C, we can use the law of sines now. We know that this is an obtuse triangle here, so we really do sine of 20 degrees divided by 6.56 is equal to sine of C divided by 15. Again, we want to find angle C now, right? And we know that the angle C here must be greater than 90 degrees because it's an obtuse triangle. So now we do 15, cross multiply 15 times sine of 20 degrees. Obviously 6.56 goes there, so we're really saying divided by 6.56. And if we do the inverse of this, sine a -1 of that should give us C, right? And so if you put this in your calculator, you will see that C, it must be an obtuse triangle. It must be an obtuse angle, obviously. But once you put this in your calculator, you see that C is equal to 51.4 degrees. So this is what you're getting when you put this function in your calculator, because it's only giving you the angle in the first quadrant that makes this true. However, we know that this must be an obtuse angle. Therefore, we're really looking at the second quadrant. And if you recall, we are trying to get a reference angle that is 51.4 degrees in the second quadrant. Now, that angle must be 180 minus 51.4 degrees. Because if you recall, in the second quadrant, you have something like that. This angle here is the reference angle, right? So it's 180 minus this reference angle that we're talking about, and it's the ratio, the sine of that particular angle here, this angle, it should be equivalent to sine of this angle, because this is the reference angle, right? 51.4 degrees. So to determine that obtuse angle, we're really just saying C is equal to 180 minus 51.4 degrees, right? Because this is an obtuse angle. So if we do 180 minus 51.4 degrees, we get 128.6 degrees. So we know that our angle C here is 128.6 degrees. And obviously this is the largest angle because it's opposite the longest side. So we know these two angles. Now obviously we can add these two angles and then subtract from 180. And so we can subtract that from 180, and then we know that this this angle over here measures 31.4 degrees. Again, just adding all the three interior angles of the triangle should give you 180 degrees. So here we have found all the three angles, and we also have found our B side length. So again, using both the law of sines and cosines, we have determined all three side lengths as well as all three angles. And so it's important to understand that you should be able to classify your triangle as obtuse or acute. And then if it's acute, it doesn't really matter. You're just finding the value, whatever your calculator is giving you, by taking the inverse. But however, if you know that there's an obtuse angle, then you want to find that reference angle, and if it will be with respect to a sine, and therefore you know that in the second quadrant you have such an angle that is an obtuse angle, and it gives you that exact same ratio, which your calculator is not necessarily giving you. And so you would do 180 minus that angle, or that reference angle. And so in this case, that angle, obtuse angle, would be 128.6 degrees. And then add that and subtract your result from 180 to determine your third angle. So thanks for watching.